I do want to take the compound apart to get any gunk that is collected in there out. So that looks like that's going to be just a matter of, I think if I take those two screws out right there, I think that'll loosen that collar, and then I can just unscrew that screw from that assembly. Well, looks like I was right about that anyways. Now, I don't see any jib screws on this. Oh, there they are, right there. So on these little holes right here, down inside those holes are some really small screw heads. And there you go, this is the jib right there, you can see it. See that? I learned. I just slid that all the way back, and look at all the sawdust that fell out of there. I could probably use a jeweler's screwdriver on those screws if they're not too tight, but I actually I've got these precision screwdrivers. They're made by a company called AIM, and I think there's a couple different companies that make this style of precision screwdrivers, but they're kind of nice because they give you a little more leverage to deal with. At first I was just going to loosen those screws, but then I decided to back them all the way out because by doing that I was able to actually get the gunk that's in the holes to come out, and I'll be able to clean that up easier. Now I think this can only go back on one way, but just in case I get confused about it during reassembly, the part with the nut that the cross screw here threads into actually faces where the handle is, so I think it can only go on that way. But boy, I'll tell you, with those little jib screws loosened up, I was about to say that slides off real easy, but it's actually stopping right there and hitting something. Looks like, oh okay, can't go off that way because the nut that's still in there is hitting. So it's either going to have to come off this way. Yeah, alright, it comes off this way, or I would have to unscrew the nut. Look at all the garbage in there. That's why I wanted to take this apart. Alright. Cool beans. Let's move over to the rest of the carriage here. Alright, I think we're ready to take this door handle off. Check that. Window crank. Okay, so this little screw, this little bolt right here, looks like there's a nut on the back side, this fell off. And the handle itself, this window handle, this screw, this nut, and this machine disc. Oh, look at that. I'll look at that more closely later. I don't think that started out its life as what he had it doing here. That, Alright. Anyways, see some markings on there that interest me. So this is what this whole mess was covering up. The fact that this handle, this hand wheel for the cross slide is broken. Now, again, because this is a really early model, it's got this small hand wheel. They quickly abandoned this design and went to, again, what I call a ball crank handle. That's the handle that's got the, like a cross piece of ball on this end and then the little handle here. And it's designed ergonomically correct so you can grab it and get some leverage to turn. Or if you're doing fast work, you grab the little handle and give it a crank. So this is real unfortunate because I really would love to make this original again. And I did find one of these online, but the problem is the seller who's got this, he's selling the handle with the whole rod assembly, and you know, he wants a lot more money for it than what I'm willing to pay. If I have to, I'll take this off and put a ball crank on, but I might just hold out and see whether or not I can find somebody who's got one. Alright, get the stuff in the parts cleaner and we'll get going. Alright, got those parts cleaned up. I'll just wipe them all down. You know, it's funny. Cleaned that up pretty well, or so I thought. And then I was just turning this and looking at the way the gears mesh, and you see it? There's a big chip in there. Right there. That's why you don't want chips getting down in here. Alright, I don't see any damaged teeth, which is good. But in there I can see a big pile of gunk that I missed. I'm going to clean that out. Here's a good look at what I missed. Alright, I put it back in the parts washer and hit it again. This time I used an old toothbrush. Got right down in there and cleaned that all out nice. Down inside that hole. You can kind of get a pretty good look at the way this works. This is a very simple lathe. What I mean by that is all we've got is we've got the hand wheel for the carriage to manually move the carriage right here. And what that does is that turns this gear, which turns this gear, which meshes with the teeth on the rack that's on the bed of the lathe. And then you've got a lead screw that goes through here, but there are no teeth in here. And what you've got over here is you've got this device here. This is called a half nut, and you can see it's kind of it's like a big thick nut that's split in half, and then this lever on the outside here actually actuates it. So what happens is you've got that lead screw sitting in there turning, and nothing's happening. You flip the lever, that closes the lead screw. That closes the half nut onto the lead screw and causes the drive to engage for threading or for feed. Now, you've only got this one lead screw going through here, and the same half nut is used for the thread feed or for feed when you're turning. And there's no cross feed on this lathe. Now, I'll show you on the Hendy what a better lathe will have. So on the Hendy, you've got quite a different setup. You've got a separate drive shaft that drives the mechanism as far as moving the carriage back and forth, and then you can actually flip a lever and it transfers that drive to the cross slide. So this has a power feed on the cross slide, and then for threading, you would disengage that drive and you'd flip this lever here, and this engages your half nut. So basically the same thing that we've got on that other lathe, only much beefier, and that engages this big lead screw on the top here for your threading operations. And I believe down that end there's a lever way down there on the left, far left hand side. I believe that allows you to disengage the drive to the threading lead screw when it's not in use. So when you're not doing threading operations, you can have that not running. And I don't know if it's a benefit to that you're minimizing wear, or for some reason I think there's a benefit to doing that. But anyways, it's quite a different setup. I don't know what all of these exact levers do. I'm pretty sure this engages the, memory serves me, this engages the feed. This is a half nut, pretty sure. This part right here on the face is called the apron. This, I think, might be the knob. Not sure what that's almost just feeding that. That must, I think there's a certain way you push this or pull this and it engages that feed. I don't know. I'll worry about that. I just purchased an old owner's manual for this. I'm waiting for that to come in. Alright, getting the carriage back on is pretty easy. Just kind of keep the back tilted angle up so that you can get the gear underneath here to mesh with the rack, and then drop that right down on the back way there. And then of course Part of the reason why that's so easy to do is because you can see it's sloppy as heck because I don't have the jib in there yet. Alright, so these are the two parts I think I originally took out. Well, I know this is the part I took out. That's the, I believe this is the jib for the carriage. Yeah. And I got this piece here. Why do I not know what that is? Oh, okay. This piece I believe goes up underneath the underside of the back there and locks that in. Yeah, that would make sense. Okay. So this isn't really a jib. I thought this was a big part of the jib. Yeah, I thought this was the Andy jib and this was the Barry jib. Alright, now I'm standing on the back side of the lathe because it's going to be a lot easier to get the jib in from the back here. So I've got these all loose, and what I'm going to have to do is I'm going to have to back that off. And then it's pretty obvious to me that, you know, this side with the indentations is where the ends of these screws are actually going to ride in. Okay, getting these end ones in, it's pretty easy to tell when those were in. I was just sliding the jib back and forth a little bit and feeling with the tension on the screw until I felt it pop into the hole. So I've got the two end ones in, but what I'm noticing is I'm tightening these two down all the way, and I still got a mess of play in there. So I'm going to back these nuts off. I'll tell you, I don't like it because I've got these nuts backed off as far as they'll go because these two bolts are not, they're not all thread, and it's better, but it's still not that good. These appear to want to tighten down. Now, even that one there. It's funny, this is the only one that seems to want to reach far enough. I'm going to try flipping that. I don't think it's going to make a difference. I'm going to try flipping that jib end over end. Well, I don't know if it was a combination of me flipping the thing end over end, or I also tighten these up some more. That seems pretty good. Now the question is, how free does it move? And the other thing you got to take into account is it might be snug right there. You know, is it going to be too loose over here where the bed has more wear on the ways, and then too tight down when you get away from that headstock end? So you got to take that all into account. Oh, by the way, I should have prefaced those previous comments by adding the fact that I really don't know what I'm doing. I'm basically flying blind here. I'm not even sure if this is the proper method to go about adjusting this jib. I do know I'm not doing anything that's going to cause irreparable harm. I'm not tightening that up so tight that it won't move. At least I don't think so. Let's try it. I'm having a little trouble getting that hand wheel on, and it's a little tricky to do this with the hand wheel partially off, because what happens is if I slide the hand wheel in, it disengages the gear altogether. But it seems like it's pretty good. I mean, I haven't even really oiled the ways yet, so I kind of like the way that feels. It's getting a little tighter down this end. Yeah, that makes sense, right? That's where it would be tighter, because this is where you're going to have more of your wear concentrated, because this carriage probably spent the majority of its life going back and forth in this area right here, doing facing operations and turning on shorter items, and it only got down here on the rare occasions where long pieces were being turned or threaded. So now it's getting significantly tighter down here. I mean, not so much that I can't turn it with I could still turn it with just one hand, but I'm definitely going to readjust that jib so that it's got a little more play over here, and then it's just going to have to be sloppy down here, which is going to be indicative of a lathe that's got some wear in it. Again, we figured out this is between a 1932 and a 1934 lathe, so it's been around the block. So I just took all of the tension off of the all four of those jib screws, the adjusting screws, and see now that this thing is just moving smooth as glass. Let me get this stuff out of here. Come on. So what I'm going to do is I'm going to run it all the way down to this end here. Let's see. It's never going to really get down this end, this far, because the tailstock's going to be here. So I think that's about as far as it's going to go. So this area here should have a lot less wear. So I'll adjust it here so it's just a hair tight. And then that way, hopefully, when I run it back down this end, it won't be too sloppy. And the reason why you can't keep it tight down here and have it start getting too tight coming up here is because if you've got the automatic feed advanced, that lead screw, you know, something's going to want to break. On this lathe, what breaks when you have a lathe crash or something that causes the carriage to not be able to go further when it's supposed to is there's a bracket on the end here that was designed. It was purposely designed in a way so that it would snap, and what that would cause was once it snaps, it would cause the lead screw to unscrew itself from the gearbox down here to save the bevel gears that are inside here. So I'm going to show you when we're putting those in. Alright, so the way I'm doing this is I'm wiggling this right here back and forth in this motion right here until it's just snug, and then I hold this screw in position while I tighten down the locking nut. And then I do the same thing on this side and tighten that one down. And now I'm going to touch these down until feel, and then lock those down. Okay, I think I've got that snugged up the way I want it. It's just a little tight, but I don't plan on being down this end with the carriage very often. And what's happening is as I go towards the headstock, it's loosening up because I'm getting into that area where there's more wear. Already it's much easier right here. And then of course, I run it all the way down. Oops. Again, I've got to kind of pull out on that handle as I'm going. Alright, so right down here, here's your, see if your compound's right here. You know, the chuck's right here. You're probably right in this area right here when you're doing your facing operation on small parts on the lathe and turning. So let's see what kind of play we've got here. There you go, you can see it. See if I can zoom in on that. You can hear it knocking, so you can obviously see that. That's how much that's moving. But hey, you know, that's life. So I'm going to have to cancel that appointment. I had some aerospace guys coming over here that were going to make some parts for some jets, and I don't think this is going to have the proper tolerance. It's not going to be able to produce with the kind of precision we need for that job, so I'll have to cancel that. Okay, I just bolted that little plate on the underside here. It's got 3 little bolts that hold it on, and that's what keeps this from being able to lift off the back. And that's still working the same, so that's good. Now, I'm not going to put this hand wheel on permanently because, or all the way, because I haven't decided yet where I'm going to go with this hand wheel. This is the one that actually came off the tailstock end. For those of you who didn't see my earlier videos in disassembly, this is what was on there. This is a homemade, well actually what this is that centerpiece right there is part of the original hand wheel, and what probably happened was the hand wheel broke, and the gentleman who owned this lathe before me took that centerpiece of the hand wheel, turned it down, press fitted into this aluminum blank that he made, and made a little handle on it, and it's actually a nice little working handle. The only reason I'm not using it is because I want to try and make this more original, so that it's more of a not just a working lathe, but also like a collectible. And I had already talked about it earlier, but I'm going to talk about it again real quick. You'll notice there's no chrome plating on this. This is a very early version of the 9-23 hand wheels, and a lot of them have chrome on them. And I'd love to have another one that matches this one, but these are harder to come by. And when they do pop up on eBay and that, they typically bring $35 or $40 just for the hand wheel, which I really don't want to spend that kind of money. whereas sometimes you can get a chrome one for 20 bucks. Not only that, but if I wanted to, I could change the handle to a ball crank type of handle, which is more typical of what was on these 9-inch lathes after like 1935. This handle also would have been changed to a ball crank handle, which is actually more practical from a point of using it. And see, no, this may have stayed a hand wheel. I think this went to a ball crank, and I think the compound went to a ball crank, which is a compound. That again is not very practical, but that what's nice about it is that that's an original. Well, I tell you what, the battery on the camera is dying, and it's getting late, so I think now's as good a time as any to quit for tonight.